So here is our second speaker, Jeff Lilly, talking about lost English, generating words that weren't quite.
All right, thanks. Yeah, so I'm just going to jump right into it here. I'm going to present a program I wrote to generate words that don't exist but could have. So here's an example. This is where it is frith. It's a noun. It means the act of asking or the act of questioning. And this is just like a regular dictionary entry you might see. It's got a Middle English form, Old English form, going back to Proto-Germanic and Proto Indo-European. I'm not going to try to pronounce the Proto Indo-European in this, unfortunately. But it comes from a root meaning ask, and then a suffix to, which means an abstract noun. And you can see it's related to Latin precor and the Scottish frine. So this is a word that's not in English, but it could have been. But for whatever reason, it was dropped somewhere along the way in the last thousands of years as all the words descended through time. But we can recover it if we assume that the regular rules of sound change occurred in English and all the languages between now and then. Here's another couple of examples. Yimage, meaning wintry, from an old root meaning winter, and the eco suffix of an adjective. It's related to Latin heims and Sanskrit hema. There's also this one I think could be really useful. Swifter is an aid to sleep, a treatment for insomnia. So, you know, you can't sleep, you go and you take a Swifter. And this goes back to the Proto-Indo-European swep for sleep and tro as an instrumentive suffix. This is a lot of fun to do, and I started doing these a couple of years ago just to sort of see, are there any cool words we could generate if we just assumed that they weren't lost sometime. But it was labor intensive. There are a lot of sound changes that occurred. So I thought, you know, is there a better way to do this, to generate these fun little words? And I thought, you know, probably a lot of other people who struggle with this daily. So I decided to put together a program for that. So this is PyBot. It's an open source thing. I'll share the link to that. It's a simple Python package. It takes a set of Proto-Indo-European roots and suffixes and generates the modern English words from them, along with a guess at the spelling. I do want to caveat that this is not a work of scholarship. You know, I did my best, but I'm a computational linguist and not a historical linguist. In any case, these aren't real words, so you can't really say for sure what the modern form would have been. And the sound changes between Proto-Indo-European and today, they're not all known. Of the ones that are known, they aren't all studied very well. And a lot of them are not as systematic as you might assume by looking at the equations. So the program really only models the systematic sound changes. It doesn't take into account the interactions of various English dialects at different times. Obviously, no borrowing, anything else like that. But it would be useful for anyone who's working on an alternate history, who might think, well, maybe there's, you know, what sort of other words might there have been in English depending on different historical currents. If you're working on historical fiction set in Middle English times or something like that, you want to use a word that you don't have actual evidence for in the text, you could generate this. And also, it's just good, clean fun for everyone in the family. The sources I've got here, I drew the Proto-Indo-European roots from Wiktionary, which means that the data required some cleaning. And it didn't get entirely cleaned, but at least it's there. I also got a bunch from the American Heritage Dictionary of Indo-European Roots 2011, which was awesome, but I didn't have a digital copy of it, so a lot of that had to be put in by hand. The sound changes in the program from Proto-Indo-European to modern English I took from a concise history of English, which has the major ones and a bunch of smaller ones too, but it can't be viewed as completely comprehensive. I put in the suffixes and the sound changes by hand, and I'll show you an example of how that was done. When you run the program, it first loads in all of this data, the roots and suffixes. It's got cognates in there, the meanings, and the pronunciations. The pronunciations are coded in Xampa, which is the ASCII form of the IPA. And so when you interact with the program, that's often the easiest way to do it. If you're not familiar with Xampa, it's a Wiktionary article, Wikipedia article on it. That's very good. It's pretty intuitive once you get to know it. And then there's, it also uses an English spelling generation model file. It uses a simplified n-gram model to generate the spelling. I'll show that also. And then what comes out of the program at the end is a modern English spelling and pronunciation. It shows you the derivation through the different stages of English. By default, it only spits out a few of the major stages, but if you want to, you can go in and put in print statements throughout, so you can print out every single sound change if you wanted. It also gives an approximate suggested meaning based on the Proto Indo-European and any other cognates it's got in the database. If you look in the right-hand corner of the slide at the top there's an example of how you'd actually call the program. You go Python, pybot, and then there's a -r to give you the root, the Proto Indo-European root you want for it. And I'll talk about this in a second, but you can give the pronunciation, you can give a written form like you might find in a Proto Indo-European dictionary or in the etymological section of the American Heritage or something. Or you can give a meaning, and it will find an English meaning. It will go and find a root that has that meaning. You can optionally give it a suffix, and then it will spit out the spelling, the pronunciation, all the things there. So the way it does it is first it loads all this background information in to the memory. If you've asked it for a suffix, it combines it with the root before it does any additional processing. So it assumes that the root and the suffix were together in Proto Indo-European and then went on down history as a single lexical unit. Then the sound changes are applied step by step. Most of them I just do with regular expressions, but in some cases where a regular expression wasn't particularly handy for it, I used more of a procedural in the code system for doing it. And then it generates a spelling and then prints the output. The spelling model, as we know, modern English spelling is clearly perfect as it is, but it is idiosyncratic. I think anyone would have to admit that. I experimented with deriving the spelling directly from the Middle English pronunciation because a lot of the English spellings are sort of frozen during that Middle English to Modern English transition. But that didn't work so great. There might be a way, I might come back to that at some point and play with it some more. But what I ended up doing for this iteration anyway is a sort of a stripped down simple anagram model, which just looks at, given this pronunciation, given this spelling in existing English words, what are the probabilities that it's spelled this way or that way? And I tweaked it a little bit to eliminate things like, lots of times English F is spelled with a PH from Greek. I wanted to remove that because none of these roots came from Greek. So did some tweaks like that. So the spelling system works okay, but you are urged to use caution when doing it because it can be dangerous. Here's a couple more outputs that I found when I was playing around just for fun. We have nijwan, which means to narrow something down or filter something out, from the Proto Indo-European nik, to winnow or filter, and then a suffix of an abstract verb. And then igel, which I was delighted to find means a juvenile hedgehog. I was ecstatic when I saw that Proto Indo-European does have a word for hedgehog, and that we somehow lost this amazing word. I think we should contact the Oxford English Dictionary and get this in here as soon as possible, because this is clearly objectively the word for a juvenile hedgehog. Okay, so that's the main part of the slides. I'm going to cut over now to the demo. So let's see if I can do this. There we go. Is this going to be okay if I just present like this? Is this clear?
Yes, I can see your screen, no problem.
Okay, awesome. All right, so let's just do. So if you want to run it and give it a particular root from Proto Indo-European that you know about, this is a little tricky because the way that the roots were pulled in from Wiktionary, there's a lot of variations in how the laryngals are represented in Wiktionary and some of the other quirky sounds. So here's one. It's often better to give it a pronunciation, which is usually, I've converted all to Xampa within there, so that's easy to do, or to look for it using the English meaning. But here's one, you give it the root pel there, and it runs through the changes, and we get fail, F-A-L, which means skin. So that's just a simple example of that. You can also, if you wanted to give the Xampa or the IPA, you could say like that, and you put spaces in between so the phones are clearly delineated, and you get the same result. Let's try a different pronunciation. This is pent.
Sorry, Jeff, there's a couple of comments in YouTube asking if you could increase the font size so it's a little easier to see.
Hopefully a little bit more. Okay. Hopefully that'll be good. Sorry about that. Yeah, so then you can put pent in. Again, if you put it using phones, you want to put a space between each one so they're clearly delineated. And that generates finth, and that's a kind of road. I could imagine that coming down to be a certain type of road, maybe. Maybe a, I don't know, it feels like a thin or narrow one, maybe not well paved. Let's see, you can also put in the English word. So for star, it goes back and finds a Proto Indo-European root, stare, or however you'd say that, and it comes down correctly, and you see the pronunciation and the spelling there. We even got the spelling right, which is awesome. Let's try one that we know didn't make it. So the Proto-Indo-European word for bear did not make it all the way to English. Possibly because bears were so powerful, you didn't want to accidentally call it to you. It is true that modern bears in our national parks, if you say bear, they will seek you out because they think that you've got food. They've learned their own name. So, but what if it did survive? What if it did make it all the way down? So here we have a case where the spelling system didn't really work out great. It looks like something that should be pronounced Earthus. And you can compare that to the Welsh term arth, which is pretty cool. You know, if the program generates something like this, the spelling program, you know, it's iffy. So you'd probably want to tweak that a little bit if you wanted to use that in a work of fiction or something like that. If you don't give it a root, it will find one at random for you. So let's see what it shows us. Okay, so this is wood, an old word for wood, and it comes out with tar. I think actually this root, yeah, I'm not sure. Anyway, yeah, so that's a word that, unless I miss my guess, it's either should be door, and there's a problem with the sound changes, or this actually is a root that was lost, and we don't no longer use the word tar to mean wood. Or maybe it's just a meaning shift. I don't know, I haven't looked it up. Using the random form gives me lots of cool stuff that makes me wonder about what happened. So then with the suffixes, let's go back to star. You can add the S for suffix, and I'm going to use lo, which is a diminutive suffix. And that gives us a sterile, which means a little star. And that's pretty cool there. From the Old English sterla. And with suffixes, you can also ask for a random suffix. This is cool too, because there's a couple of dozen suffixes in Proto-Indo-European that are really useful and give lots of quirky words. But to do that, you have to give it random like that. You can't just let it default to nothing because the default is no suffix. So tell it a random suffix. This time it's giving you an abstract noun, starter. So an abstract version of a star, which might be like starage or starness in general, maybe. Or we could try again. This is a comparative adjective, starther, so it'd be more star-like, perhaps. Now, we don't have all the roots in the database here. I know there's some that are missing from Wiktionary and my other sources. And also, of course, we don't know all the roots that were actually there. So if there's a root that's not in the database and you want to give it a shot, what you can do is use the -n flag and give it a pronunciation. So I happen to know that it's missing the old word for sheep, oi, in there, but you can give it the pronunciation like that, and it'll say, okay, that's a Proto-Indo-European root, fine, I'll run it through the changes, and we get you, which is, of course, a female sheep in modern English. It didn't get the spelling right, but I'm not surprised about that. So that's cool. Yeah, and then, of course, there's the -h flag if you want to have this all laid out of how to use it there. Okay, I'm just going to I have a few minutes left, so I'm going to show you the code in the package, just real quick. So this should be a completely open source, freely usable package. If I didn't, this is the first time I've done this, so if I didn't set the licensing right, someone can let me know. This is the JSON list of roots. Oops, made the wrong thing. Here we go. So it's organized by the spelling of the root as it was in Wiktionary. So that's a little awkward because it's fine usually, but often inconsistent in how, especially how the laryngeals are represented. You have different cognates here, and then a meaning and the pronunciation. I did go through and make sure the pronunciation was cleaned up. So the pronunciation in Xampa is usually a good way to look them up. So there's a few, I think there's close to 1,000 in here, which is pretty cool. The suffixes, there's only a couple of dozen, but they're very cool and very useful for going through if you wanted to have abstract versions or instrumentatives, which is cool. And then this is the spelling model, and then this is the code itself. It has the inputs and the outputs here, some cleaning up stuff. But the bulk of the code is, I think it's pretty clear. You just have the sound changes applied one by one. Here's the Proto-Germanic changes as you go down, the Old English changes. And like I said, most of these are just regular expression changes. So if you know that, you can add a new one or fix it. Great vowel shift, yeah. So yeah, that's the core of it there. So I'll yield the rest of my time.
That is so cool, Jeff. Thank you. Lots of comments in YouTube. People talking about your bear example there, and public service announcement. If you go to Banff Provincial Park here in Alberta, it's a provincial park, not a petting zoo. The first question was from Melissa M. Can you use this to derive modern English from Old English or Proto-Germanic words as well, or just PIE?
You could. I didn't put in the flags for that, but it'd be very simple to adjust the program to do that. That's a great idea.
Yeah. From Matthew, this tool could also be useful to see where modern English words don't match up with expected outcomes. Any thoughts on that, or from a computational linguistics point of view, comparing what's expected versus what's reality?
Yeah. So one interesting example was egg. If you put the old, I forget what it is, the old Proto Indo-European word for egg in there and run it through, you get I, which was a word for egg in early modern English. I think Shakespeare uses it sometimes, but the word egg we use today was from a different dialect, which went through an additional or missing sound change as opposed to most of what we use. So yeah, that's a case where we would predict I, but because there are a variety of English dialects in the area at the time, the main channel of received English borrowed from another dialect, and we get egg instead. So yeah, you definitely find examples like that.
Really cool. From Hex, and I think this might be a two-part one because I just saw a second half show up. Assuming that modern English is a simple root, or perhaps with just a few suffixes, could one theoretically use this program to reverse engineer the Proto Indo-European word? And related to that question, can I request to have a hypothetical English word run back to Proto Indo-European? I have a rough spelling through Xampa, although I have no idea about the suffixes.
So I can't do that. It's not set up to do that. That would be cool, but the way the regular expressions work, you can't run them backwards. So it's in that sense, the program is poorly designed. It will only run in one direction. You'd have to basically rewrite the whole thing backwards, do it the other way, and which could be done, and it would be easier, I guess, than starting from scratch. But
yeah. From Yoshimitsu, I assume the IPA given from the modern English entries are for GAE specifically. You did admit it was idiosyncratic. I'm curious, though.
The spelling. I'm sorry. The spelling generator is, yeah, I trained it on an American English lexicon. Is that the question? I'm sorry.
I can't quite interpret, but I assume IPA for modern English uses GAE. So is that General American English?
Yeah.
Okay.
So, yeah. So the the pronunciations that it generates are British English,
Okay.
but the spelling was trained on an American English dictionary. So I'm not sure if that causes a mismatch really or not, because the spellings are, obviously there are differences between UK and US English spelling conventions, but
Yes.
yeah.
And from Lycan, now that I know how to pronounce that with Slavic N, is it possible to invent unattested Proto Indo-European roots and shunt them through the program?
Yes, absolutely. So if you wanted to take your name and say, okay, what if my name was a word in Proto Indo-European, and run it through, you would see what the modern English would be. So I actually did that with, let's say your name was Thomas. You want to put it in as a new root like that, and you want to say, give it, the phones you put in have to be Proto Indo-European phones, or it'll throw up, which is not pretty, but that's what it does. You run it through. If the name Thomas existed in Proto Indo-European, it would come out as Thamer. So, or Thama, yeah. So yeah, yeah, you can do that.
That is really cool.
I tried it with my own, and unfortunately, it just comes out as Jeff. So it's kind of sad. Or maybe it's just I'm eternal,
Jamin says the output equals reverse Canadian. Jeff is always Jeff. Any other questions from any of the presenters that are on here, or from anyone else in YouTube? There's a lot of excitement, Jeff. If you have a chance to check out the YouTube chat after you log off here.
Oh, that's great. Thanks so much. It's a great opportunity to present here, and I want to thank for what you guys are doing such a great job with this. Everything's running super smoothly. It's clearly a lot of work. So thanks for that.
Hex is asking, can you run modern English words through the program as if they were from Proto Indo-European? I think that was the example you kind of gave with Thomas there.
Yeah,
but it has to have. Sorry.
It's what you were just about to say. It does have to have Proto Indo-European sounds. So you have to either map them to phonemes that were in Proto Indo-European, or leave them out or something.
Mladen, I just tried running this locally, but a file is missing. Did you forget to check in xsampa2ipa.json, or where would I find that online?
Yeah, I'll pull that in there. Yeah, I definitely did. No, it's just a simple dictionary to convert the xsampa from my IPA. So
right.
I'll put that up there in the next hour or two.
And Fundrick, I wonder if the sound changers could be written in some markup language and replace the sound change functions with just parsing those files.
I imagine. It's not. I don't know all the different markup languages and which one you have in mind. I did consider, instead of putting all the sound changes just in the code, putting them out in a JSON file so it'd be easier to see and edit and move around and read that in also. So that would get you partway there.
Sorry, go ahead.
I was going to say, some of the sound changes are not easy to represent in regular expressions. So a more complete language, a more complete context-free language would be better to use, no doubt.
I'm enjoying the YouTube chat. People are helping me with pronunciations as best they can in YouTube. I assumed Mladen, and I don't even know how I'm saying that, was a Slavic name just because the ML sequence, but I guess it's with an A as in far. And I don't know if I physically can produce that sound in Mladen. Logan is saying you could do it with contextual replacement rules. That's the popular way of doing computational morphology these days.
Cool. I should do
that. You have your rest of the year work cut out for you, right. I suppose.
Awesome.
All right. Well, if there's no other questions, thanks so much, Jeff. That is incredibly cool. I don't know if I have the skills to to run that program myself, but I still haven't figured out the sound change applier. I'm still doing everything manually.
Thanks so much. It's been great.
Awesome.